Hello students, back again with the chapter complex numbers. Look here, I have divided this chapter into 4 parts. So I am going to cover slowly all the topics in complex numbers, because in the beginning I am not going to take any past paper questions in this lesson. Okay, so all basics and all your concepts should be clear from the first part of AAHL 1.12. This is for AA as well as for AI. Okay, so let us start here. So real and imaginary parts. If Z is equal to A plus BI, where A and B are real numbers, then A is the real part of Z and written as REZ. Okay, and B is imaginary part of Z and it is written as IMZ. So real part of Z, imaginary part of Z, where A is equal to square root of -1. Okay, so please remember, square root of -1 is I. Okay, imaginary, or iota also sometimes we can call it. Now for example, if Z is equal to 2 plus 3i, then real part of Z is 2 and imaginary part of Z is 3. So I hope this is clear to you. If Z is equal to negative root 2i, then real part of Z is 0, because there is no real part. There is only imaginary part here, isn't it? You can see that there is only I, okay, minus negative root 2i. So therefore, in the second example, there is only imaginary part. So imaginary part of Z is negative root 2. So please note that we don't include I in the imaginary part. We just write the real number. So real part as well as imaginary part, both of them are real numbers. Okay, that is why in this definition it is mentioned like that. So I hope this is clear to you. Now what is complex conjugate? Okay, as you know the rationalizing factor, isn't it? You must have studied in lower classes the rationalizing factor. In the same way, here we have complex conjugate. Okay, what is complex conjugate? So if Z is A plus BI, then its complex conjugate is denoted by Z star and written as A minus BI. So if there is plus sign, then we just change that plus sign to minus, and vice versa. If there is minus sign, then we change it to plus sign. So for example, if Z is equal to 3 plus 4 iota, then Z conjugate is 3 minus 4 iota, or 4i. If Z is equal to 2 minus 5i, then Z conjugate will be 2 plus 5i. So note that if there is plus sign, then to write its conjugate, we just change the sign of imaginary part. Remember that we only change the sign of imaginary part. Okay. Similarly, here there was negative sign, so we change it to positive sign. Okay. So this becomes the conjugate of 2 minus 5i. I hope this is clear to you. Okay, now look at the properties of I. Because we will be dealing with I, so it is better that at this stage we discuss about all the powers of I. Properties of I means different powers of I. So just I is square root of -1. You all know about it. I square, so square of root of -1 will be -1. So I square is -1. I cube will be minus I. Now how do you get I cube is equal to minus I? I cube you can write as I square into I. I square is -1 into I. So therefore it becomes -I. So please remember that I cube is -I. Then I4 is 1. This is very important property of imaginary number I, because with this we can simplify any higher powers, converting them to the powers of 4. Now look here, why I4 is 1? Because I4 is equal to I square multiplied by I square, right? I4, I square multiplied by I square. The first I square is negative 1. The second I square is negative 1. So negative and negative will become positive 1. So like that we get here positive 1. Then 1 over I is negative I. How do we get that? 1 over I multiplied by I in the numerator and denominator. So numerator will be I, denominator will be I square. And we know that I square is minus 1. So this minus sign will go up, and like that it will become negative I. So 1 upon I is equal to negative I. Okay. Now let us solve some examples based on these powers of I. So I7, how can we write I7? I4 times I cube. Now I4, as we have seen here, okay, in the earlier part, I4 is 1. So therefore this will become 1. And I cube also we have seen, so it is negative I. Look here, negative I. So like that, 1 into negative I is negative I. So I7 is negative I. Then I200. So 200 can be 4 times 50. We know that 4 times 50 is 200. So I am writing I to the power 4 bracket to the power 50. So this will cover 200 power. Now why I to the power 4? As I told you earlier, I to the power 4 is 1, and 1 to any power, whether it is 50 or whatever, is always 1. Okay. So like that I 200 becomes 1. Now I 70 plus I 1 upon I 30. I 70 I can write as I to the power 4 bracket to the power 17. As I said, I want to use I to the power 4. So 17 for the 68, and then remaining 2 powers I am writing separately. Okay. Now this, all these powers of I will get converted to 1 and 1 to the power 17. Okay. And I square we already know it will become minus 1. Okay. Then in the second part, I30 I will write as I4 to the power 7, which will be 28, and the remaining 2 powers I am writing separately. Now I to the power 4 is 1. So 1 to the power 7 I am writing here. And I square is negative 1 I am writing here. So 1 into negative 1 is negative 1. 1 over 1 into negative 1 is negative 1. So negative 1 plus of negative 1 is negative 2. So I hope you understood this. Now next example, simplify I to the power n for n is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And similarly, negative 1, negative 2, negative 3, negative 4, negative 5. Okay. So this example is given so that your concept of power is clear. So any letter, whether it is I or whatever, to the power 0 is always 1. So therefore I to the power 0 is 1. Then I to the power 1 will remain I square will become minus 1, I cube as we have seen earlier is negative I4 is 1, this is the most useful power. Then I5 is I4 into I, so I4 is 1, 1 into I is I6 will be I4 into I square. I4 is 1, I square is minus 1, so therefore answer is minus 1. I7 is I4 into I cube. I4 is 1 and I cube is minus I, so therefore answer is minus I. I to the power 8 will be I to the power 8 becomes I to the power 4 bracket square, and I to the power 4 is 1, so 1 square is 1. So therefore I to the power 8 is 1. I to the power 9, I will write I to the power 4 square, which will be 8, and 1 separate power of I. This is 1, so 1 into I is I. Here is the answer. Now see the negative powers. I to the power minus 1, I to the power minus 1 can be written as 1 over I, and then multiply by I in the numerator and denominator. So numerator is I, denominator is I square, so therefore I over negative 1, which will be negative I. I to the power negative 2, as it is in the numerator also I square is negative 1. Similarly, this is in the denominator, so negative 1. Okay, 1 over negative 1 is negative 1. I to the power negative 3. I to the power negative 3 is I will write it in the denominator first. So 1 over I cube, and 1 over I cube is minus I, because you know already I cube is minus I. And now I will multiply by I in the numerator and denominator. So denominator is minus I square, numerator is I, and this will become negative 1. So I over minus of minus 1, which will be plus 1. So final answer of I to the power minus 3 is I. Okay. Then I to the power 4, as it is in the numerator 1, in the denominator also it is 1. I to the power 5 will be I 1 upon I to the power negative 5, sorry, it is negative 5. 1 upon I to the power negative 5 will be positive 5 in the denominator. Okay. So 1 upon I to the power 4 into I. 1 upon I to the power 4 is 1, so into I, multiply by I upon in the numerator and denominator. Denominator becomes I square, numerator is I. So final answer is minus I, because this will be negative 1. So therefore minus I. So I hope this is clear to you. Now next example we will solve here. Okay. So I to the power 4n, where n is any integer, plus 3, I will split both the parts. So I will write I to the power 4 bracket to the power n into I to the power 3. Why I am doing like that? Because plus can be separated by multiply. Okay, plus in the power. Now I4 we know that it is 1. So 1 to the power n. Multiply by I cube is negative I. We have already seen here. Look here. I to the power I cube is negative I. Okay. So like that, final answer is negative I. So I hope this is clear to you. Okay. Now note that when imaginary part is a radical, okay, square root 2, square root 3, square root 5, then write I and then the radical sign. For example, 2 plus I root 3. So first write the iota letter I and then the radical sign. But if it is an integer number, then 2 plus 3i can be okay. 2 plus 5i can be okay. Okay. But then if there is a radical sign, then or a square root number, then write first I, then the square root part. Okay. So 3 plus I root 5, so that there is no misunderstanding that I is inside the square root. Because of that, it is written in this way. So I hope you will remember this. Okay, next question, question 5. Express z is equal to 3i over square root of 2 minus I plus 1 in the form a plus bi. It means we want it in the numerator and there should be real part and imaginary part separately. We don't want any denominator. So let us start it here. So z is equal to 3i over root 2 minus I. What I will do? I will multiply by conjugate. So by now you already know The conjugate of this of negative will be positive. So root 2 plus iota plus 1 I will keep as it is. Now the denominator will be a square minus b square. By that formula, a minus b, a plus b. Okay. And the numerator will be 3i into bracket root 2 plus I. Plus 1 I will keep separate. Now the denominator is 2 plus 1 because I square is minus 1. So minus of minus plus 1. Numerator will be, we will open the bracket. So iota or 3i root 2 like that I can write plus 3i square because I and I square plus 1 as it is. Now denominator is 3. My numerator is 3i root 2 minus 3 because I square will be negative 1 because of that. And plus 1 as it is. Now what I will do, I will take 3 common from the numerator. So I am going to get negative 1, the real part I will write first, plus I into root 2, the imaginary part I will write next, over 3 plus 1. Now this 3 and 3 will cancel. So my answer is minus 1 I root 2 plus 1. Plus 1 and minus 1 will become 0. So my final answer will be 0 plus I root 2. Okay. This is in the form of a plus bi. Okay. I hope you understood this. I am going to upload this PDF. Don't worry. You can always download my PDFs. Okay. It will be always there in the link will be always there in the description. So even the previous ones you can go now to my YouTube channel and download that. Okay, now this question is simplify I over 1 minus 2i. Okay, so the first part what I will do, I will multiply it by its conjugate, complex conjugate. So 1 plus 2i, 1 plus 2i because it was minus. So I'm going to multiply it by plus. I will write it in one line so that I can complete all the questions. So 1 square minus 2i square. Okay. A minus b, a plus b. So that will become 1 is a square minus b square. So I hope you will remember it. And the numerator will be I into 1 plus 2i. Sorry, I forgot to write 1 plus 2i. So I into 1 I plus 2 I into I square. Okay. I am multiplying this with this and I am multiplying this with this. Okay. So denominator will be 1 minus 2i square and I square is minus 1. So therefore minus and minus plus 2. So 1 plus 2. Numerator will be I minus 2 because I square will be minus 1, isn't it? This I square will become minus 1. Okay then. So my denominator is 3. Okay. And numerator is I minus 2. So I will write real part first. So minus 2 over 3 plus 1 over 3i. So this is in the form a plus bi. So I hope you understood this. Second part b, I into bracket 2 minus I over 3 minus 2i. What I will do, first I will open the bracket in the numerator. So 2i minus I square. Now the denominator is a complex number, so I will multiply it by complex conjugate. So it was minus, so I will multiply by 3 plus 2i. So I hope you will understand it. Now again, a minus b, a plus b. So 3 square minus 2i square. And numerator is first bracket 2i and minus of minus 1. Look here, this is minus 1 and negative sign already there. So plus 1 and then second bracket 3 plus 2i. So denominator will be 3 square 9, and this minus and minus will be plus 4. So 9 plus 4, 13. My denominator is 13. Now numerator I will multiply and open. So 2 3s are 6i plus 4i square plus 1 into 3, 3, plus 1 into 2i is 2i. So I'll get minus 4 here. Okay, minus 4 plus 3 minus 1, and then 6i and 2i, 8i. So plus 8i. Now 13 I can separate. So always you have to write real part separately and imaginary part separately. So I hope you understood. Now question C part of it. 1 upon 2 minus I will multiply by the conjugate, complex conjugate, 2 plus I, and minus second part. This was the first part. Second part was 2 upon 2 plus I multiplied by again its conjugate. Otherwise, what we could have done, we could have taken the LCM of that. Okay. So that way also you could have done. Anyway, I have already done this. So let me solve this way. You can try by taking the LCM also. So first denominator will be 2 square 4 plus 1, because I square is minus of minus I square is plus 1, and numerator will be 2 plus I minus, again here denominator will be 4, because 4 plus 1, 2 square 4, and minus I square will be plus 1, and the numerator will be 4, 2 times 2, 4, and minus 2i. Okay, so both the denominators are 5. So I will write the common denominator. Then numerator I can simplify together. So by minus I will open this. Minus 4 plus 2i. So finally my answer will be 2 minus 4 minus 2, and 1 plus 2i, 3i, and the denominator 5 I will write with both of them. So like this I got the final answer. I hope you understood this. Now equality of complex numbers. When two complex numbers are equal, then we write real part is equal to real part and the imaginary part is equal to imaginary part. Okay. So when two complex numbers are equal, real parts are equal and the imaginary parts are equal. So real part equal to real part and imaginary part equal to imaginary part. For example, by using this, we can find any unknown part. Okay. So for example, x plus 2i is equal to 5 plus 2i. So when we compare real part with real part, we get x is equal to 5. Similarly, x plus yi is equal to 3 minus 4i. So this implies real part equal to real part. So x is equal to 3 because this is real part, this is real part. So they are equal to each other. And the imaginary part y is equal to the imaginary part minus 4. So y is equal to minus 4. Okay. So like that we can find the unknown integers. Okay. Properties of complex conjugates. What are the properties of the complex conjugate? So z conjugate of conjugate becomes z. z1 plus z2 bracket conjugate can be separated with plus. So z1 conjugate plus z2 conjugate. Similarly, the minus z1 minus z2 bracket conjugate can be separated with the minus sign. So z1 conjugate minus z2 conjugate. So plus will remain plus and we will write separate conjugates of both, and minus will remain minus and we will write separate conjugate of both of them, z1 and z2. Now the product of z1 and z2 bracket conjugate will become z1 conjugate multiplied by z2 conjugate. Similarly, Z1 upon Z2 bracket conjugate will be Z1 conjugate divided by Z2 conjugate, provided Z2 is not equal to 0. Otherwise, it will not be defined. Okay. Then Z to the power n bracket to the power conjugate, Z to the power n conjugate will be Z conjugate to the power n. So conjugate and the power can be interchanged by each other. Okay. So for positive integers n, of course for the positive integer n, if it is negative integer, then you have to be careful about it, because conjugate of a negative or conjugate of a denominator will be different. So it is only true for positive integer n. Then Z1 plus then Z plus Z conjugate and Z into Z conjugate are always real. Okay. I can show you example of this, Z plus Z conjugate. So let Z is equal to 2 plus 3i. So therefore Z conjugate will be 2 minus 3i. Okay. So therefore Z1 plus Z conjugate will be 2 plus 3i plus 2 minus 3i, and when we add them, only the real parts will get added and the imaginary parts will get cancelled, isn't it? Plus 3i minus 3i will get cancelled. So this is only the real. Okay. Similarly, Z multiplied by Z conjugate will be 2 plus 3i into 2 minus 3i. So when we multiply them, we use the formula of a plus b, a minus b, a square minus b square. Okay. So 2 square minus 3i square, which will be 4 plus 9, because I square is minus 1. So minus of minus will be plus 13, which is again real. So that is why this property says the addition and the multiplication both are real. Okay. Now this is exercise. We will solve few questions. So show that Z1 minus Z2 bracket conjugate is equal to Z1 conjugate minus Z2 conjugate. The property just now we have seen. So that we have to prove here in this question. So anyway, no problem. What we will do, let Z1 is equal to A plus Z1 is equal to A plus BI and Z2 is equal to C plus DI. Okay. Let us take them like that. So therefore, I will take the right hand side. Z1 minus Z2 bracket conjugate will be equal to Z1 means A plus BI minus C plus DI bracket conjugate. First I will simplify inside the bracket. So real part and real part I can write together. So A minus C plus of B minus D with I and bracket conjugate. Now I will apply bracket conjugate. So therefore there is plus between real part and the imaginary part, so it will become minus according to the conjugate rule. So A minus C minus B minus D iota. Now this we can simplify further. So we will write A with minus BI. So A minus BI, and then minus will be common from this. So look here what I am doing. I am writing this with this and the minus sign. So it will be plus now. So minus C plus DI. Then I will take minus sign common. So minus of C minus DI. Now the first one is Z1 conjugate. The second one is Z2 conjugate. So therefore we have proved that Z1 minus Z2 bracket conjugate will be Z1 conjugate minus Z2 conjugate. Okay. So I hope you understood this. Now next question says, prove that for all complex numbers Z and W, okay, Z plus W conjugate plus Z conjugate W, Z into W conjugate, sorry, I said plus Z into W conjugate plus Z conjugate into W is always real, that we have to show. Okay. So what I will do, I will again take Z as A plus B iota. So let A plus Bi and W is equal to C plus Di. Don't think that it is omega. Omega is another thing. We will study that later on, not now. This is W. So in the A part, we will write Z into W conjugate plus, or let me first write Z conjugate and W conjugate, then we will use it. So therefore Z conjugate A minus Bi and W conjugate will be C minus Di. Okay. So first I will write it down. Now I will use it in part A. Z into W conjugate plus Z conjugate into W is going to be, Z means A plus Bi. W conjugate is this. So C minus Di multiplication plus Z conjugate. Z conjugate is this. So I will write A minus Bi first into W. So W is C plus Di. Okay. So we wrote all of them. Now we will multiply it out. So A into C will be AC. A into D will be minus ADI. So AC minus ADI. Then I'll open with BI. So plus BCI. Then this with this minus BDI square. So this is all expansion of first two brackets. Plus similarly the second two brackets I will multiply. So AC plus ADI, then with minus BI, so minus BCI and minus BDI square. Okay, so now AC plus BC minus AD, I will write together I, and this is going to be minus 1. So minus 1 into minus will be plus BD plus AC, and these two together I will write AD minus BC bracket into I, and this is minus 1. Minus 1 into minus will be plus BD. Okay. So now I will simplify all of them together. So look here, AC and AC is 2AC. Okay. Then BD and BD is 2BD. Okay. And then look at these two, BC minus ADI and AD minus BCI. They are going to cancel each other. So like that we don't have any imaginary part, so which is real. That is what we had to prove. Now B part, Z W conjugate minus Z conjugate W is purely imaginary or 0. So B part, let us start with B part. The same imaginary complex numbers we are going to use. So first let me write Z into W conjugate minus Z conjugate into W. So remember that first we have used plus. So the answer of plus is real number. The answer of minus for the same thing, they said is purely imaginary or 0. Okay. So again I can multiply the same thing, only remember that there will be minus sign here. Okay. So I will write it directly because we already have it. A plus bi into c minus di minus a minus bi into c plus di. So I will write this bracket as it is and this bracket as it is, because this sign only I will change. So AC minus ADI plus BCI minus BD I square and minus between them. AC plus ADI minus BCI minus BDI square. Okay. So just I have changed the sign between the two brackets. Now AC and this minus I square will be minus 1, which will be minus and minus plus BD. So the first bracket will have AC plus BD, okay, together, and these two are together, plus BC minus AD I minus, here also minus I square will be minus and minus plus, so AC plus BD and plus AD minus BC bracket I. Now look here, I will open it with minus sign, so AC plus BD plus BC minus ADI. Now this will be minus this first bracket and second bracket will also be minus. So look here, this and this are opposite of each other, they will get cancelled. Then we are left with BC. Okay, let us open the bracket and simplify so that you understand it well. So BCI minus ADI, I am just opening the brackets, minus ADI plus BCI. Now BC and BC will be 2 BCI, this with this, and the middle two together minus 2 ADI. Now I can be common between them. 2 also can be common, but no need to take out 2. 2 BC minus 2 AD bracket I, which is imaginary, purely imaginary. So that is what we had to prove. Okay. Now I think there is one more part, C. So I will add one more page to this. Yeah. This ending line I will take down. Then let me copy that part here as it is. Okay, so I have it here, and we already have Z is equal to A plus BI and W is equal to C plus DI. Okay, please remember that. Look here, we have both of them here. Or let me color it, highlight this. Okay, so A plus BI is Z and W is C plus DI. So this will be Z means A plus BI divided by W means C plus DI. Okay, and this I will directly multiply by the conjugate of denominator, complex conjugate of denominator, C minus DI, C minus DI. So this and this I am getting multiplied together, then plus between them. So Z conjugate will be A minus BI, okay, in the numerator, A minus BI in the denominator, W conjugate, so C minus di in the denominator. Now I will multiply it by the conjugate of denominator, complex conjugate of denominator, so it will be plus C plus di, C plus di. Okay. Now this denominator will be C square minus di bracket square. Numerator I will have to multiply and open it. So AC minus ADI. Okay, so look here, AC minus ADI. So I wrote that. Now I will write BCI minus BDI square. So plus BCI minus BDI square. I will extend the denominator. This is all together now. Plus here also the denominator will be C square minus DI bracket square. Now numerator again the same way, AC plus ADI. So AC plus ADI. Then minus BCI minus BDI. So this is together. Okay. Now both the denominators are same. So I can club them together. So I will write them together. Now what is the denominator? C square minus DI square. So look here. C square minus D square I square. Then I square is minus 1. So minus and minus plus D square. So like that it will be like this. Okay. So therefore denominator is C square plus D square. And numerator we will write all together. Okay. So AC minus ADI plus BCI minus BDI plus AC plus ADI minus BCI minus BDI. So I wrote all of them in under one denominator. Okay. Now look here. What will cancel? All the imaginary part will get cancelled here. So minus ADI minus plus ADI. Okay. So I'll choose red. ADI will cancel. Then BCI with minus BCI. And there must be some mistake here. So let me check that. So BDI square it was. Yes. It was BDI square. Okay. Because when you multiply this with this, it is going to give you minus BDI square. So I square will become minus 1 and like that minus and minus plus BD. So what we are left with are only real parts. So the real parts are AC and AC, 2AC. Okay, this AC and this AC is 2AC. And here also I did mistake. Look here, BDI square minus BDI square. So here I should have written I square. So good that I checked it. So it will be plus BD, okay, minus and minus plus BD, there will not be any I. So now plus BD and plus BD will be plus 2BD over C square plus D square, okay. Now this is all real, so which is a real number, okay. So with this, we end this lesson. Okay. So I hope you enjoyed my lesson. Yeah. So if you have liked my lesson, then please like, share and subscribe my channel so that you can get my next lesson immediately as soon as I upload it. Every Thursday and Sunday I upload one lesson. Okay. I was late today. So it is 11:50 now. So anyway, within 10 to 20 minutes, I am going to upload this. But again, also remember one more thing, that if you have any suggestions about my lessons, okay, for example, if you want me to cover some particular topic, then write it in comments, okay. I will surely consider it and try to start that topic, okay. You can contact me also by my email, or you can contact me on my WhatsApp, okay. And this PDF will be available in the link given in the description of my YouTube channel. Okay then, bye for now.